means the probability of heads. Probability of flipping heads. Okay, so we flipped heads. We had a result of 3. Now this is experimental. This is what we actually did, right? This is experimental probability. This is the actual testing we did. So we took a coin. Looks like we flipped it 10 times, and I wound up with 3 heads out of 10 flips. So 3/10 equals 0.3, which equals 30%. I don't care which way that you guys represent this. In fact, either one of these is fine. 3/10, 0.3, 30%. To tell you the truth, I don't care if you just give me the fractions with probabilities, even if they're not simplified, just to make life easier. I'm not testing here on whether you could simplify fractions or change decimals to fractions or percentages and all that other stuff. So, just to make your lives easier, just leave it as a fraction. Okay, so that's experimental, when I actually do the experiment. Theoretical. What's the theoretical probability of getting heads or tails? Yeah, 50%, right? Okay, so you see the difference between experimental and theoretical? Good. Number 1. Suppose the spinner was spun 60 times. Alright, so right off the bat, we know that our denominator is what? 60. And it stopped at the number 4 on the dial 14 times. What is the experimental probability the pointer will stop at 4? Now, that's easy. Now, if you really want to, you can simplify it. Let's see, 7/30ths. And if you want to give me a decimal, it would be 2 point, no, 0.23. And if you want to give me a percentage, it would be 23%. I'm okay with you guys just giving me 14/60ths. That. What is the theoretical probability that the spinner will stop at 4 on the dial? Let's see, 1, 2, 3, 4, 5. 1 out of 5. Boy, you guys are good. Variety spin. What is a theoretical probability? Theoretical probability that the spinner will stop at 3. It would be the same. Suppose that number 3 came up 42 times out of 60. Would you conclude that something was wrong with the spinner mechanism? So the number 3, we happen to get 42 out of 60, which, I mean, you might want to actually do this one, which is 0.7 or 70% of the time. Would you, oh, I'm sorry. Actually, I'm not. Would you conclude that something was wrong with the spinner mechanism? Yes. Why? Yeah, it's over 20, way over 20%. What could be wrong with our spinner? Get stuck or sticks at or bent, or the metal pin is bent. Something wrong with the spinner. Okay, number 5. Weather records for the first week of May for the last 10 years show that it rained on 14 of the 70 days. Based on this data, what is the experimental probability of rain during the first week of May? Isn't that easy? This is actually 2/10 or 1/5, right? A standard roulette wheel has slots 1 to 36 and 0 and double 0, where the ball can land after the wheel stops spinning. Anybody play roulette?
Only Russian roulette.
And you're still here.
I think it was my BB gun.
Wow. BB gun Russian roulette.
Well, I have a remote. You individually load.
Did it actually go off?
I was pointing it at Not that.
Did it go off?
Yeah, it was a CO2.
Did it hurt?
No.
No.
Of course it hurt.
You're funny. Okay, what is the theoretical probability that the ball will land in the slot number 7? Well, we have slot number 7, 1, and we have 36 and 0, 37, 38. Actually, this one's pretty good to, let's go ahead and divide that out. Maybe not. Nobody's got a calculator. It's probably pretty small. That's why you guys never win. That's why people never win at roulette. It's really hard to win in roulette. Because you only have a 2.6% chance of winning. That's pretty low. Maybe you played Russian roulette. Number 7. A poll of seniors showed that 110 favored Thursday Pharmacy for senior class president.
Thursday Pharmacy.
100 favored Aurora Martinez, and 40 were undecided. Total seniors poll equals 250. What is the experimental probability that a randomly chosen senior will vote for Thursday Pharmacy? No, 110. 110 out of 250.
And we got a worksheet.
Number 8. Student tosses a coin 20 times and recorded the results. The experimental probability of getting heads. So the probability of heads, experimental. See, 7 out of 20. Theoretically, be 1 out of 2. This is easy. Easy peasy. Let's do a couple of these. I'll let you do the rest for homework. Number 1. What's the, oh, here's our data. Here's our data. This is our experimental data. Okay. The probability of getting a 7, experimental, let's see, we did, I'm assuming that's 5 and 4, so 9 out of, how many spins? Oh my gosh, we got to count them. 4, 9, 16, 19, 27, 34, 43, 50. Nine out of 50. Theoretically, it would be 1 out of 8. Yes. Yeah, 50 spins total, right? Oh, shoot. Probability of a 1. Let's see, probability of a 1. Experimental, they did 1, 2, 3, 4 times. Or a 5, so we're going to have to add 8. All out of 50. So I get 12 out of 50. Theoretically, we should have 2 out of 8, or a quarter. Probability of a 3, let's see, that's 7. Or a 4, which is 3. Or a 5, which is 8. Or a 6, which is 7. Or a 7, which is 9. All over 50. So 10, 18, 25, 33 out of 50. Theoretically, 1, 2, 3, 4, 5. Out of 8. How about number 6? A multiple of 3. So a multiple of 3 would be 3 or 6, correct? So a multiple of 3, which is 7 plus 6, we did 7 times. 14 out of 50. And 2 out of 8, which is a quarter. You guys get the gist of this? No. It's how you become an alcoholic. Yeah, I come to school drunk every single day. You really think this is coffee, huh? All right, I think you guys could do the rest. I think you guys could do the rest of this chart. There's her homework.
Did you have any copies you needed?
I'll send them next hour.
Okay.